guys, so today we're going to be recapping the double slit experiment based on some of the quantum mechanical properties we've seen. So as you may recall, the double slit experiment is one where there is basically a sheet with two slits like here, and photons are passed through both of these slits, and there's a big detector back here, and there we go. Now that's clear. And this detector basically detects, instead of the expected pattern, just those two. There's a spectrum of electrons that are detected all across the detector. And we built one of these mini detectors at home. I have mine with me right now. And so if I shine this light, then you can see a fairly large spectrum. It's not the best, but it's what we work with. Fairly large spectrum of light, whereas compared to if I remove it, then it's just one dot, one full bright dot, just like that. And so what does this experiment tell us, right? So this experiment, it basically tells us that these particles, right, instead of just acting as particles, they act as waves as well. So this is what we call the wave-particle duality. So you can think of it as a particle being led on and acting as a wave. And what it also shows us is the probability, right? So on the detector here, you don't know whether the electron's there, here, there, wherever it's going to land. Where it lands and the fact that it lands in these lines is pure probability. So the fact that it lands here might have a 20% probability, and same here. Here might only have a 10% probability. And as you get further from the two holes and from the exact locations, the probabilities simply decrease like that. Okay, and so we've talked about probabilities, wave-particle duality, wonderful. So how does this apply to our regular models, right? So if you recall the Bohr model of the atom, it states that you have the nucleus surrounded by the electron rings, right? Well, in fact, these are not actually electron rings, but or orbits, but they're what we call orbitals. So what's an orbital? It basically states that nucleus is surrounded in areas where there's a high probability of the electron being found. And so these areas are called orbitals, and they're simply probability. And you can do some more advanced study into that, but this is all I'm going to be talking about for now. So we have quantum physics, we have wave-particle duality, we have the double slit experiment, which is very important, and we have science. And so see you all later. And this is tau. Sorry, the camera flips me, so let me see if I can write it like this. This is tau signing out. Thank you very much.